Windows users and anyone else who hasn't used Linux before. My name is Ivan, and this channel is all about making you an IT pro fast. In today's video, I'll be showing you some of the basic history behind Linux, the distribution types like Ubuntu, which is the one we'll be covering. We'll also be setting up a virtual machine using VirtualBox. So that's the easiest way to really get your feet wet in Linux without dedicating a machine or using hardware you might worry about. Then I'll show you some command line utilities, how to get yourself around, and then also how to use the desktop setup that you can also install with Ubuntu. So let's get started. Okay, before we dive into using Ubuntu Linux, I want to make sure that you understand the difference between Linux and Windows and why is there even other operating systems and a little bit about their history. I feel that's very important to understand what you're using. So first, let's talk about where Linux comes from. And it actually is a derivation, it was derived from an older operating system that was called Unix. And Unix is actually basically like the granddaddy of a lot of popular operating systems, OSs, that I'll refer to them from now on. Not only Linux, but Mac OS, so anything that you've used on an Apple or a Macintosh is Unix based. There's also BSD, if some of you have heard of that, and obviously Linux. And it all goes back to Bell Laboratories in the 1970s into the 80s. They developed an operating system that they called Unix. And Unix was revolutionary, okay, at the time. I mean, we're talking, this is before DOS, this is before anything. This is before you could just turn a computer on and it worked, okay? Another thing you got to realize in 1971 is for the most part, we're still looking at machines that are at least the size of, your dresser drawer set, okay? We're still looking at terminals here. This is before you had the microcomputers. This is before the Apple I. This is before all of that. So we're talking early 1970. They came up with a revolutionary idea. And it's kind of funny to us today that it's revolutionary, but it was. And that is, any file is merely data. You don't care what's in it. You don't care what it says. You don't care where it's going to go. It's just a file. And it just has data in it. And that is the basic principle behind what made Unix so revolutionary. Because at the time, previous operating systems didn't work that way. They always tried to say, this data is a Word text file. It must be handled and processed this way. This file is something else. It must be handled and processed this way. This file is memory. It must be handled and processed this way. And what that did was it made the operating systems really complicated to program. It made them really unwieldy. For the most part, they weren't successful. When they designed Unix, they changed everything. All of a sudden, data was data, files were just files. And it just went on from there. The other key success to the Unix operating system was the fact that they had a brand new high-level language to program it in that they also created at Bell Laboratories, which was C. C, for those of you that don't know, is, again, the foundational languages of just about every high-level programming language there is. I mean, there's C++, Java's been inspired by it. I mean, everybody, any object-oriented programming somehow gives itself back to the foundations of C. And for non-programmers, by the way, high-level languages mean that you can read it as a human in human words, but it gets compiled down to code, to machine code, that the machine can read. So you're getting down to those ones and zeros. Prior to high-level languages, you actually had to program in what was called assembly, which was sort of a halfway between humans and machines, but not really. It was still very machine-like, and it took a lot of instructions to do anything. There were other high-level languages at the time, like Fortran, but Fortran didn't have the flexibility or speed of C, especially with the compilers that they were able to put into Unix. So by the time they get done with Unix, they have a machine that can have multi-user accounts. They have a machine that can handle all sorts of, drivers for peripherals. They basically have a machine that can do everything that we think of a computer doing today. But back then, this was revolutionary. This was brand new. Everybody wanted to play with it. The problem was that it was owned by AT&T because AT&T was Bell Labs' owner. And so what happened was universities, smaller developers, people who wanted to use Linux but couldn't necessarily, pay AT&T for the license, they didn't steal the code, okay? That didn't happen. The source code for Unix was never stolen. But what they did was they started learning from Unix. They started realizing what were the core principles behind it, and they were able to make different Unix-like operating systems that used the same command lines that were programmed in C, and these are the ones that I've put in the parentheses. Berkeley, which is where the B comes from, created their own Unix spinoff, which is called BSD, and now there's several versions of that. Obviously, Steve Jobs and company, they made a Unix-based operating system that they used in their Apple computers, and now serves in Mac OS, iOS, anything. And then, of course, Linux, which is actually partially named after its creator, a guy named Linus, which is cool. So Linux comes out and explodes in popularity, okay? And the big reason that Linux explodes in popularity, it's because it comes out as something called open source. And this hadn't been done before, or if it had, it wasn't as widespread. Because before this, even Unix was a proprietary operating system. It was owned by a company. You had to license it to use it officially. And those licenses were expensive. Linux, on the other hand, was distributed with a simple premise. If you build upon it, anything you make, share back. Share it back, and you can use it for whatever you want to use it for. And this changes everything. All of a sudden, you not only have a Linux kernel that runs one OS, you have several. And so we call them distributions because they're all Linux based. They're all basically the same, but they all have their little flavors, twists and turns. Now, you might be asking me, especially if you're a Windows user, why would I use Linux? What is the point of Linux? Why do I keep hearing so much about it? Okay, so let's talk about some of those things, now that I've history nerded you out a little bit. All right, so the first thing you got to know about Linux is it does by far run more efficiently than Windows. This has been proven in test after test. When you take it to the bare metal, it will win. In memory management, in space on your hard drive, on boot up times, it will beat Windows flat. Now that doesn't mean that it's better than Windows at everything, because obviously it isn't. Then Windows wouldn't be dominating the business world. But what Linux really is good at is being there for a lot of different purposes. This is why it rules the web, as we like to say. Most web servers, even those run by Microsoft companies, are Linux based. They are running Linux on those servers. In fact, Azure itself, which is Microsoft's cloud services, mostly runs Linux virtual machines. There is a reason. They are easy to develop on because just about any software runs on them natively. They are easy to set up. They are easy to deploy, maintain, and again, the big one here when it comes down to business bottom line, free distribution under the GNU license, meaning you can have 1,000 Linux virtual machines. You can scale up for any purpose, and guess what? You're not paying a license on any of those. Okay, so the first thing that is going to throw you, especially when you're coming from Windows, and don't worry because I actually came from Windows. I was a solid Windows user I kept telling people, I'm not going to use Linux. I don't need it. Let someone else love Linux. That didn't happen though, because when I got into cybersecurity, Linux is where all my main tools are. It's what all the main web servers are running. So I needed to learn it. And the first thing that's very intimidating when you're a Windows user is the file structure. We have all grown up with C drive, okay? We did. We grew up, whether you can go back to DOS and say C DOS run, and you get the joke. Or if you're newer and you just know it, it's in my computer, you click on it and it's C drive. We are so used to drive letters, and it freaks us out that Linux doesn't have them. But don't worry, I will explain how this works. Okay, so in Windows, you have C drive, okay? Then if you have a CD-ROM, you have D drive, okay? Now, if you're old enough and you remember floppies, they were actually A and B. So for any of you younger folk who are wondering, why do we start with C? It's because back in the day, floppy disk used to be your A and B because you usually needed two. So, and then obviously when you started adding flash drives and such, we went on to, all the other letters. You can just keep going. It's pretty neat. Though usually my floppy drive comes in as J, which is fascinating. Okay, but without getting into all of that, the reason Windows does this is because each drive is a separate entity memory-wise, right? It's all isolated. And I started making an analogy between the two ideals, and later down the line it'll make sense. I won't go into it now. But what you have to realize about what you're seeing in front of you, which is the Linux file structure, is it makes sense once you start realizing that what it's doing is taking all the files that is in Windows that are usually kept in program files, and it's spreading them out amongst directories that do that job. They organize the programs you have running. They organize the logs of those programs. They organize the configurations of those programs. It's just they're making it actually a lot easier to find them. Because say in Windows, okay, let's say I'm running something like the Elastic Stack, which is a search engine database stack, okay? In Windows, if I'm running it, I need to go to program files, I need to go to Elastic, and then I need to find all of its separate logs, which could be over in program data. Windows, one bad thing about Windows is it doesn't always put things in the same places. So just because I know where everything is in that Elastic folder doesn't necessarily mean I know where it is for, say, my Steam games, which is a whole nother problem. Which doesn't mean I know if I put an Apache server on there, where those files going to go. Here's the thing. Linux makes that so much simpler. And this is why I'm trying to get across that actually Windows file structure doesn't make as much sense when you start learning about Linux. Linux will make so much more sense to you. Okay, so let's get into it. This / means root. Okay? Root is the highest place that can exist. It is the master of the universe, basically. Okay. Now notice that there's also a root here. This is meaning the root home. Okay. These are the files that are going to belong to root. However, just know that this little / is your highest level of everything. Okay. So let's start looking at this. Let's say I install Elasticsearch, okay? Or Apache web server, or a game, or anything. This is the cool part. First of all, the files that actually run it are going to be found in binary, or bin for short. Configuration files are found in etc by default. Now note the word default because sometimes programs will they'll load into a subfolder like user, Oh, that's funny. It's showing up. Yeah. Okay. When I move the mouse around, it shows up. That's hilarious. Okay. So user, and then they'll have these little sub files in them, but they're still the same names. That's the neat part, is that they don't change the name just because they, put it somewhere else compact wise. But this is the general structure and it holds true. So your binaries are in binary, or bin for short. Your configurations are in etc. Your logs are most likely going to be in var, along with any other libraries you need. Devices that you mount are exactly where you think they might be. Okay. Media, if you have, other media devices plugged in, they'll show up there. Boot, that's pretty self-explanatory. That's what happens when you boot something. Now, when you get to user, SBIN kind of thing, this is where you start, and home, you start dividing things up according to, how you're going to install a particular program, because users have home directories. Okay. So if I have my traditional user of IPN on a Linux machine, my home is going to be // because I don't need another one, home, and then it's going to be another / and then IPN. And that's going to be my home directory. Now, my home directory, I have all the things, and you'll see this once we load it up. I have all the things you have in Windows. By default on a desktop, I have my documents, my downloads, anything. But I can also install programs there. And basically what happens when you do that is it makes like a little mini version of this larger setup. So you'll have your bin and etc, but it will be, for that program, it will be in that home directory. That way you can separate things according to users, because not every user wants to use the same programs. They don't want to have the same dependency libraries. They don't want to have the same setup. Another thing you have to realize about when Unix was made, and Linux consequently does the same thing, is that at the time everybody was sharing computers. Okay, again, the computers were the size of at least dresser drawers. If they were more powerful, they were the size of a room. So not everybody had a laptop like the one I'm recording this on. So they had multi-users. They called it time sharing. And so by default, this system is made to allow multiple users to use the same computer and have completely separate environments. So that's why you have the home, and then also you have optional ways of even separating applications. You can load them up from the opt directory, or you can install them in the USR directory. But the neat thing about it is that once you do that, yes, the program's in there, but then you still have a bin, var, and etc folders inside of those little subfolders. So no matter where you install the application, the file structure, that easy to find, here's my logs, here's my configurations, here's my binaries, is maintained. And that's the beautiful part about it. So if I'm running my traditional security stack and I got Zeek monitoring my network, I can tell you exactly where the configuration and log files are. Just like I can say probably where the Suricata log files are, because again, it's always the same. It always makes sense. It's going to be in the var logs, either in the main system one or where it was installed. If it was installed, say, in USR or opt, depending on how they did the install. Most default installers these days use a USR, and then they'll use the local because they want to say that it was done locally, in case you're running, like a network machine or something like that. So it's pretty exciting, actually. I mean, because, for instance, when I run security stacks, no matter what software they're using, the first place that I look for a configuration is an etc, because they're most likely there. So I don't actually have to know the software to know where its files are going to be. You can predict it. It's predictable. And that's the power, really, of the Linux file structure. Okay, so we went over the history of Linux, we went over why it rocks, and we went over a little bit about the file structure, just because I wanted to say a bit before we got our hands dirty. So now it's time to get down and, like I said, dirty. Okay? So we are going to download Ubuntu Desktop. Now, Ubuntu is one of the most popular distributions of Linux. It's also considered the most user-friendly for new users. I personally use it as my flagship, meaning that anytime I need Linux, I go Ubuntu. Just a little bit about Ubuntu is it's actually based on a very popular, originally popular distribution called Debian, which is one of the main distributions. You can kind of think of it like a family tree. Debian is like, the parent of Ubuntu, okay? Ubuntu is one of its children. But Debian tends to be lacking in a lot of features. It doesn't add as much tools and software for you. And so a lot of people have migrated onto Ubuntu because it's kind of pre-built with a lot of things out of the box. And that makes it easier to run. So we're going to look at this because there's various options and I don't want you to get confused about what they are. Okay? So we are downloading the newest version of Ubuntu Desktop. And by the way, LTS means long-term service. And so that means that from a business perspective, you are getting at least 5 years guaranteed of free security and maintenance updates. So it's usually best to use their LTS. I use it even if I'm just running basic projects because it's going to be the most stable and secure. It's going to get regular updates. And, you can keep using it for 5 years even when newer versions come out, which is nice. So there are other ones that we can be downloading. I'm going to open these in new tabs. You can do Ubuntu Server. Now, Server is exactly what it sounds like. Now, for those of you who might not be familiar with the term server, or maybe you're confused. What's the difference between a computer and a server? Okay. A server is basically a specialized computer. Its whole purpose is to provide clients with services, whether those are web services, whether they are SSH services, whether they are VPN services, whether they are Elasticsearch services, it doesn't matter. It's there to be the server for the client in our network architecture. Now, just so you know, a server could be a physical server on my desk. It could be in a data center somewhere off, and be providing cloud servers, which are basically virtual container servers, virtual machines. But they're still considered servers. They're still an entity that you can load applications on and have to protect and all that wonderful stuff. So that's the basis here, is that you would be putting Ubuntu on your server. Now they have various architectures that you can consider. For now, we're not going to get into that in this video. It's a little beyond scope. But that's just to know. Now, the main difference between Ubuntu Desktop and Ubuntu Server is that Ubuntu Server won't have a GUI, a graphical user interface. There won't be, things to click on. It will be pure command line. It won't have all the extra software. It's meant to be streamlined. It's meant to be secure out of the box as much as possible. So it's not going to have a lot of extra stuff in it, just what you need to get started. Now, they do have a lot of nice templates that they let you choose from for different stacks. A stack being a set of services that produce some sort of outcome, some sort of application you want to run. For instance, they have various web stacks in case you're running a web server. They also have SSH out of the box, so you can do secured shell connections, things like that. They actually added quite a bit recently. It's amazing. Very useful. So as you can see, beyond just desktop and server, they have quite a bit. They have direct cloud setups. You can run it now on a Raspberry Pi, which is a really small one single board computer, and they're really fun to play with. You can do all sorts of fun lab experiments with them. To be honest, if you don't own a Raspberry Pi and you haven't played with one, that should be what you do next. You know, after this video and after you've set up your Ubuntu desktop and learned a bit about it, go get a Raspberry Pi, play with it. You'll learn so much more about Linux. You'll learn so much more about networking and security, and it'll just make you a better IT person in general. In fact, maybe we should do some Raspberry Pi videos in the future. Who knows? Okay, so without going into that too much, I just love them. IoT, Internet of Things. Ubuntu has recently been trying to support smart devices more, creating really small builds of Ubuntu that, excuse me, that will fit into things like smart light bulbs, smart thermostats, robots, anything that is smaller than a desktop, smaller than a Raspberry Pi probably, but still needs an operating system that has a kernel, that has the ability to be updated with secure patches, things like that. Now, when I talk about a kernel, I'm getting down into the guts of how a digital device works, because we're talking about memory management, we're talking about driver management. When it's drivers are the things that make it talk to the things that you plug into it. So a mouse, a keyboard, a graphics card, any of those things need drivers, and so we're getting to the guts of these things. Although kernels technically are even below drivers, funny enough, they're like the root of everything. And that's really what Linux is at its base. It's just a kernel that controls all these things. Ubuntu is the full operating system that then makes it possible for you to use it and do things and everything. Just to get that clear so that you have a better understanding. We want to make you IT pros, and pros know these things. Okay, well, at least that's how I figure it out, whether they're a pro or not. Okay, so the main point in the end is download Ubuntu Desktop. You click download, it downloads. Now, the other piece of software you're going to need is called VirtualBox. VirtualBox is your best friend when setting up labs, because it actually allows you to set up full running computers within a computer. Think of the movie, what's it called? The Dream one. Wow. Total fail. Okay, but think of the movie with the dreams and dreams. That was bad. Can't remember what it's called. Has Leonardo DiCaprio. The point is that in the movie, they have dreams inside of dreams, right? They go into your dream, and then to get to a deeper level of your mind, they go into another dream. That is exactly what we're doing with VirtualBox. We are literally on your computer, and we make another computer. So we're not just remaking like an interface that looks like a computer. No, it is really a whole nother computer. It has its own RAM, its own hard drive, its own network cards, its own everything. It's pretty neat. And scary enough, if you really want it to, although I don't suggest it because things start getting really weird when you do, you could make a computer inside that computer. Yeah, you could download VirtualBox, run it, and create a computer inside a computer. But like I said, I don't suggest it because from what I hear and from what I played with, weird things start happening. Who knows why, but they do. Okay, so VirtualBox specifically, this is important. It specifically only works on x86 and AMD 64, Intel 64 architecture. What that means is you can do anything that's supposed to be on a desktop, but you can't do things that are on other architectures like ARM. ARM is basically anything, it's used mainly when you have a mobile device, it's used on Raspberry Pis, it's used in your cell phones, things like that. So Here we're a little limited, but to be honest, most of the IT infrastructure you're going to be using, at least for now, is going to be, able to run on VirtualBox. So without going into too much before we start using it, just click the big download button and you'll be good. Install it, go through the installation, and everything will be happy. Also, this is something you should probably start doing. Start using these checksums, okay? Especially when you're downloading things like operating systems and virtual machines. They should provide checksums somewhere in here. If you have trouble finding the checksum for Ubuntu, let me know and we'll add some comments about where to find it. It should just be in the download notes. Okay, so here they make it very obvious where the checksum is. So what you do is you click on this and it gives you these numbers. Okay. And what they're doing is they're taking a cryptographic hash of the file. And it's making this wonderful string of numbers that is very, 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 very difficult to reproduce and still change the file. So like, let's say if somebody wanted to put a nasty virus in your VirtualBox download, they would have a very difficult time getting that by you if you bothered to check the checksum. Now, not all checksums are made equal. For instance, notice that we are very specifically using a SHA-256. If you were to use something lower, like SHA-128, most likely that checksum could be easily made up. So make sure you're using at least SHA-256. You can also use MD5. I'm not as big on MD5 from a security perspective. It's still technically secure, but I don't like it. Notice they even have, they even have the message basically right here that the SHA-256 checksum should be favored. MD5 has been broken very easily in the past, and I don't tend to even use them anymore. I don't even tend to bother with them. Now, when you're checking the checksum on a file in Windows, all you have to do is right-click, and there'll be the option to run a checksum on it. And so it's pretty nice. You can do that just about anything that gives you the checksums, because what you don't want is what they call a supply chain attack, which is where somebody will put a virus, malware of some sort in something like VirtualBox that you're using for all your projects. And so by using a third-party software, you're inviting attack. There's actually been a very huge supply chain attack recently, like in the past couple days, where a security monitoring platform that is built in to a lot of company systems had a supply chain attack. And it had a vulnerability. Backdoors were put in the software, malware was in the software, and all these businesses downloaded the update, and now the security world is dealing with the repercussions of that. So that's why you want to check checksums. They're not always going to protect you, obviously, but hey, locking your door stops the first set of thieves. It's the same idea with checksums. Okay. So yeah, those are the two big downloads I need you to do. I also need you to install VirtualBox. Double click what you download. It will ask you for permission to install it. Just install it, preferably in the default location. That'll make it better. Okay, so now we're actually going to move into using VirtualBox. Once you use it, yours won't look like this unless you're like me and you're already using it for a billion projects. This will be blank, which is fine. As you can see, I use it. I like to create a virtual machine almost for any purpose I make. For instance, this one is an IDS. This one is what I call Detection Guinea Pig. It's a Windows system where I use adversary emulation software to attack the Windows system, and then I make sure that my elastic detections are detecting it. This one I'm working with a program called Caldera. This is another detection guinea pig, and then this one I'm doing some threat intel stuff with MISP and file, what do you call it, attack data sources. So I'm having all sorts of fun. But notice one thing I do, and this is a best practice because it'll save your life. Well, not save your life, but it'll save your time, is I have a single Ubuntu clean. Okay. So what I do is when I install Ubuntu for the first time, I take what's called a snapshot, and they have them right here. And snapshots are super, 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 super useful. They actually save exactly what you're doing on the machine. Notice that I usually have multiple snapshots on a single virtual machine. What I like to do is every time I install something or I configure something, I take a snapshot. That way, I know it was working when I took the snapshot. Or I know it was broken when I took the snapshot, and I take notes on that. So that way, if something happens later on, I can go back to when it was working and everything's happy. So what I do is when I first install Ubuntu, is I take a snapshot and I call it Ubuntu Clean. And what clean means is I haven't added anything else. Then when I want an Ubuntu Desktop or an Ubuntu Server or whatever I'm using, I don't have to reinstall it. I can just clone the virtual machine. So all these Ubuntus you see are actually just clones. I never had to reinstall it. So it saved me time. I do the same thing with Windows. You don't see the clean version here. Oh yeah, you do actually see Windows 10 clean. And then when I wanted to make guinea pig number 2, I just cloned it. So I always make that first snapshot. It's a good practice. I suggest you do it, and I suggest that you use snapshots anytime you make a change to a program installed or a program that has been configured differently, because that can break things or make them work, and either one you want saved. Okay, so I'm going to go ahead and actually go through the process of creating your Ubuntu machine now. All right, so what I've done is, just in case you don't know this little trick, I went into Windows settings, and then I went to ease of access, and I changed the size of the apps and text on the main display. I'm trying to make this a little bigger so you guys can see what I'm doing, a little simpler. So we're going to go ahead and magnify to 150%. Should be big enough. Again, if you have trouble seeing what I'm doing, just leave it in the comments and we can change this in future videos. But I'm hoping 150% helps. Okay, so what we're going to do to create a new one is we're going to go to Machine and we're going to click New. Okay? So right away, it's actually set for Windows by default. So first we're going to name it. And notice once I start typing Ubuntu, it changes. Isn't that nice? So we're going to do Ubuntu, and I'm just going to call this Ubuntu Tutorial because I'm making you a tutorial. You can call it whatever you want, to be honest. I do suggest you put Ubuntu first and then underscore and then whatever you're going to call it, because you're going to want to remember, that it's Ubuntu. The type of Linux is actually given by this little cool icon. And if you start using multiple distributions, you'll notice that each distribution is given its own icon, which is pretty cool. And if you memorize them, then you don't even have to put that Ubuntu prefix. Okay. Now, notice that they have type. Okay. So you can do Windows, you can do Solaris, BSD. Okay. Now this is very important. BSD is its own operating system type. A lot of people confuse Linux and just say that BSD is a distribution, but it's not. Like I mentioned before, it's its own Unix-based operating system, just like Mac OS down here. IBM OS2, this is an older operating system that IBM created. If you're an IBM shop, you might still be using it. Who knows? But it is its own operating system that was proprietary to IBM. Now we're using Linux, obviously. We're going to be using Ubuntu, the 64-bit. But as you can see, you could use the 32-bit, and then all these wonderful distributions. They have general in case your distribution isn't on there. You just need to know what version of Linux it's using, the kernel itself, and it will handle it. But for most major distributions, it has them down there. There's Arch Linux, there's Debian again, which I said was the parent of Ubuntu. There's Fedora, which, if I remember this correctly, is a child of Red Hat, but I'm pretty sure. Gentoo, I've never used that one actually, or Mandry, but I've never used that. Oracle Linux, again, that's one that's more for companies that are Oracle shops. Red Hat, again, tends to be used for enterprise. They have, even though there's a free distribution, obviously, because it is Linux, there's also business support versions where they can get more support than they usually would, just running Linux on their own. OpenSUSE Linux, Turbo Linux, all these wonderful other Linuxes. But for us, we're using Ubuntu 64-bit. And like I said, as you saw, when you put Ubuntu as a prefix, it should automatically do that. So we're going to go to next. Recommended memory size. Notice how small this is. It's only recommending 1 gig. Okay. Imagine trying to run Windows on 1 gig. How would that go? Not well. Now, Ubuntu obviously won't run very fast on 1 gig, but the point is that you could do it if you had to. Let's say you only had 4 gigs of RAM, and who knows how much you actually have on whatever machine you're working on. But imagine if you only had 4 gigs of RAM, you could actually run Ubuntu with only 1. Because here's the thing about virtual machines. It does actually take up the RAM resources and takes it away. Now, the virtual machine is known as the guest, okay? And whatever operating system you have on your desktop or laptop or whatever you're using is known as the host. So in my case, Windows 10 is the host and Ubuntu is going to be the guest. Now, here's the thing. When I give Ubuntu RAM, it takes it away from Windows. I have a rule of thumb. You don't need to follow this rule of thumb necessarily, but I like to with Windows. I never give a virtual machine more than half if I can help it. So I'm actually going to give, because I have 16 altogether, I'm going to give it, I think that's the double of 496. I want to say that's the double of 496. Someone tell me if I'm wrong, but I'm pretty sure 8192 is the double. That's the thing with RAM. It's good to go on PowerZip 2 because that's how it's designed. So I'm giving it 8 gigabytes, which in megabytes is 8,192. Again, if you only have 8 gigabytes for your entire system, then I suggest you give it 496. I like to give it as much as I can so it runs as fast as it can. Okay, so we're going to click next. Okay, now we're going to create a virtual hard disk now. Notice it does give a recommended size. So we're going to create, it's already on virtual disk image, so we're going to leave it there. Now here's a fun one, dynamically allocated versus fixed size. Most of the time you're going to want dynamically allocated. There's a good reason for this. What it means is, yes, you're going to give it so many gigabytes of space. However, you're not going to use it all unless you actually use it. You basically use it, you use what you use as you go. So if you're only using a gigabyte of your 10 gigabytes, then you only use that gigabyte. And you're not taking it away from your host. Now, here's the thing. If you do fixed, 1, it will take a lot longer to set up your virtual machine. And 2, you will actually be taking away the entire amount at once. For most purposes, and to be honest, I've never not used dynamically allocated. Okay, it's going to recommend 10 gigabytes. Usually, if I'm running one of these machines, I give it 100. But today, because we're just doing a tutorial, I'm going to leave it on 10 because I'm not going to use this machine for much other than this tutorial. If you want to do more things with your Ubuntu Desktop after this, you might want to give it a little more. And it's pretty simple to do that. You can just use the drag, or you can put the number right in there. If you are going to play with it more, I suggest maybe 50 gigabytes at least, just because you never know what you want to do. Just to let you know, when I do these lab machines, I usually give it 100. That way, I don't run out in case I really want to have fun. So then we're going to create. So now your virtual machine is created. So it's powered off. Notice it even has a power state. So this really is, oh, the movie's called Inception. The one with dreams inside of dreams. It just came back to me. So yeah, this is seriously Inception. It's even powered off. Okay, so now that we created the virtual machine, what we're going to do is we're going to go to settings, because we want to change a few of these settings. Okay, so these are general. We're not going to worry about any of this. We're going to go to system. Okay, the first thing you want to do is go to processor. Currently it only has 1 core. That's going to run really slow. So we're going to give it 2 just to be safe. Display, we're using a desktop, so we want this maxed out. Whatever your max happens to be, just max it. On storage, notice again, this is like Inception. It literally has all these things. We're going to come here to empty on the IDE controller. And we're going to click this wonderful little CD here. Mine are here because I've used them before. If you need to look at your disk to see where it is, just click that, choose a disk file, and then navigate to wherever you downloaded it to. But on mine, because I've used it before, I can just click on the Ubuntu Desktop. So this literally loads the ISO onto what's my virtual CD-ROM drive. So again, it's like Inception. There seriously is, involved. Like, there's even audio, and you can enable it or disable it. We can just leave it enabled, but like if you're running a server, you can disable it because, well, you don't need it. And for security purposes, you want to get rid of as many things as you don't need. Now, here's an important point. Let's talk about networking for a second. Let's take a moment, because there's different ways to network with virtual machines. One of them is called NAT, or Network Address Translation. What it will do is you're on the same network as your host, but you are behind a NAT service, meaning that your address isn't using the same network address space. You're actually going to be assigned some sort of IP address space that isn't on the network that your host is. So other people on, say, your home network, your work network, your school network won't see your virtual machine. It will be behind a NAT. And usually by default, it gets put on 10.0.0.1, just because that's the default IP address. Now, there's other ways of doing this. The ones that are most popular are a bridged adapter, which is usually what I use because I like being able to see my virtual machine on the network. I like to be able to, just directly SSH into it without having to set up port forwarding and all that. However, what's funny is some networks actually won't let you use bridged. For instance, if you're like at a Starbucks, they're not going to let you use bridge. You'll have to use NAT. But for the most part, I like bridging it, especially if I'm just at home or if I'm at work or school where they do let me do it. Although schools may not. It just depends. So what this does when it's bridged is it's literally using your network adapter that your host machine is using, and it just directly sends the network traffic over it. Notice here it's recognizing that my host is using a Wi-Fi adapter, and that's the one that I'm going to use. If I had other adapters turned on, say my cord, my Ethernet cord was plugged in, then that adapter would be available. However, for security purposes, I only activate the adapters that I actually need. So my Ethernet adapter is actually turned off currently in network settings. Now, you can come down here to advanced, And you can even choose like which type you want. Usually you want to stick with the Intel ones because they're the ones that work with most setups. If you're using a server, I always just like best practice, switch it to server, but this time we're using desktop. Promiscuous mode, if you want to check out our IDS video, you'll learn a little bit more about how to use that. For this purpose though, with just the desktop, we're not going to turn it on because we don't need to read all the traffic. Again, this is Inception, so you literally have a physical address. You have a MAC address. And it really does, its initial prefix will give away the fact that it's a VirtualBox. So, if you're trying to fool malware by running a lab, you'll want to change that. And you can actually generate random ones by clicking if you don't like it for some reason. Or you're just trying to change the MAC address if you cloned and you forgot to reset it. You can actually play whether or not it's directly connected. There's port forwarding in case you're using NAT. And you want to make sure that, say, port 22 for SSH actually goes where it's supposed to go. So you can, SSH into it. We're not going to mess with serial ports or USBs, but they're there. You can set up things like shared folders, user interfaces. Okay, but what we're going to do now, because everything's set up, is we're going to click OK. It's ready to go. So now what we're going to do is actually turn it on. And the easiest way to do that is to double click. I'll set this up like this. Now by default, it puts it in this little box because it's not set to take up your full screen just yet. You actually have to add guest editions to do that, and you can't do that till it's set up. So for the install, we're stuck in the little box. I think I can scale the little box though. Let me see what my options are. Yeah, I can scale the little box to make it bigger for the video. I just need to make sure not to scale it out of my own reach. Yeah, there we go. Okay, so Ubuntu is pretty straightforward to install. It's very user-friendly, like I said. So you can actually just try Ubuntu. Like, let's say you want to take the risk and put it on your machine before making a VirtualBox, which I highly don't suggest. You could actually just run it directly from the CD, and it will go away when you reboot. But what we're going to do is we're going to install it. If you do happen to speak another language as your first language, you can choose that language over here. English is my first language, so I'm going to leave it, but you actually have a lot of options. So, if you're more comfortable in whatever your native language is, feel free to change that. So we're going to install. It's going to ask my keyboard layout. If you don't know what keyboard layout, it will actually detect it. I happen to know that I'm using English US, so I can just continue. I'm just going to do a normal installation. So it's going to give me web browsers, it's going to give me utilities, office software, games, and media players. If I didn't want all that, let's say I was trying to make a slim install for some reason, I could actually choose minimal install, which it's only going to do web browser and basic utilities. I'm going to go ahead and let it do the download updates while installing Ubuntu because that will save some time. Now, here's one. It just depends if you're trying to stay completely open source or if you're open to some proprietary licenses. I usually click this because it means that your drivers are probably going to work better. You'll get better sound formats, things like that. So I'm going to click continue. The other trick, by the way, with the RAM is during install, I'll usually give it a lot of RAM, and then while it's running, I'll reduce it. Okay, so we're just going to keep it simple. You could go into advanced features and play with partitions and all sorts of things once you become a Linux Pro, but we're not going to do that in this particular setup because this is an introduction video, and to be honest, with Ubuntu, you don't need to do that. Everything pretty much comes out of the box the way you need it. So you're just confirming that you're going to erase your disk and install. So we're going to install now. Now, this does show you what partitions in the hard drive is going to be made. And as you can see, it gives you that it's going to be using the ext4 file format. This is the hard drive it's using, and so it's giving you what that is. Okay, so we're installing now. Install starts. You actually are going to set up a username. I just always use my initials, to be honest. So, I mean, you can call yourself whatever you want. Your computer's name. I always like naming things after ships in Star Trek, so I'm just going to call it the Defiant, which is awesome ship from Deep Space Nine. Just put some sort of password that's strong enough that, you know, your work buddies or anybody who gets access isn't going to be able to break it necessarily. I always like to leave it on require my password to log in. I don't like logging in automatically because, you know, you don't want everyone to be able to do that. Okay, now it's installing the system, and so I'm going to cut here and let it do that, and we'll come back when Ubuntu is all nice and set up. Okay, so we installed Ubuntu and we restarted the virtual machine. Now, when you first restart it, it might ask you to remove the medium that you used to install and push enter. VirtualBox does that for you, so you can just push enter and it will restart the machine. And then eventually you should boot up to this logon screen where you enter the password you made up, and then you'll be all set to go. So here's mine, entered my password, it's starting. Okay, so at first they're going to ask you if you want to connect your accounts apparently. I skip this for the most part. It's a VM. I really don't want a lot of my personal information on there. It's up to you. Would I like to set up live patch? Let's see. Yeah, we can do that. That's fine. Live patch just means that it's going to update it while it's on instead of needing it to be restarted. Oh, you can't use live patch without the notice. Never mind. Yeah, so we're not going to use live patch. You can decide, again, it's a VM, so I just say no on this, on sending information to Canonical. If it's a regular machine, you might want to do that just because, you know, it does help them with their statistics and some information, but it's all up to you. I mean, especially if you don't want to deal with, you know, sharing too much of your personal information or your location, things like that. It all depends on how you feel. It's not going to change the operation of the system. And of course, they got privacy policies for Mozilla because they use a lot of their software. And then, so apparently they've added quite a bit since the last time I installed this. You know, they have some of the more popular software packages, and you can just click and, you know, add them on. We're not going to do that right now. Okay, so right now it's telling you that there's updates you should be doing. So I'm going to show you two different ways of updating it, and we'll go ahead and let it do this one visually. This is the method of updating using the desktop. They have an application. So anytime you see like this A, it's application, okay? They have an application that's the software updater. And for the most part, it will install and update just, you know, similar to Windows. So I'm going to go ahead and let it install the updates. It will prompt you for your password again. I'm going to let it do that. Let's see how long it's going to take. I might cut the video while it's doing it. It looks like it's going pretty well. I might cut anyways, to be honest, just because I don't feel like talking through the entire updates. Okay, so let this update, and then we'll come back, and I'll also show you how to do the same thing, but from the command line. Okay, so once it finishes with its software updater, it's going to ask you if you want to restart now or restart later. Let's go ahead and restart later. Because we're going to be doing a couple other things that are going to require a restart, so we don't need to keep restarting. Alright, so the next thing I'm going to do is I'm going to go ahead and show you how you do the same thing from the terminal, because for the most part, especially if you really want to become good in IT, because servers, for instance, aren't going to have this wonderful little GUI graphical user interface. You're going to be running off the terminal. So we're going to have the terminal open. I brought it up, by the way, and let me tell you what I pushed. I held down Control Alt and then I pushed T for terminal. So that's left Control, left Alt held down, and then T. Okay? So the command we're going to use is sudo. And what sudo does is it lets you run anything with root privileges or admin privileges. So sudo, then we're going to do sudo apt, because apt is the package manager that all Debian software uses. So anytime we install something or we update it or we remove it, we're going to be using apt. Older tutorials may show the command apt-get, which is what you had to write out for the longest time on Debian-based systems, which Ubuntu, again, is Debian-based. However, you don't have to do that anymore. So, our attention span got smaller, and they decided just to get rid of the get, and you can just put apt in there. So it's just going to be apt and then update. And as you can see, even though we use the graphical interface, it still found certain packages that we could upgrade. And this is one of the reasons why I tend to run all my updates from the terminal, because it seems that certain systems, sometimes the graphical updater doesn't update them, which I find odd. So I like to do everything from the terminal though anyway, so that's just how I am. So I'm going to type clear so I can actually read what I'm doing. So we're going to do sudo again. We got to do one more command, because all that did actually was it loaded what's called the repositories. It updated our repositories. That's what we call the place where we store all the files that tell us where to get software. So to actually upgrade, we have to type sudo apt upgrade. Then we're going to give it a -y. These are called options. Anytime you see a hyphen and then a word or a hyphen and a letter, this one in particular means yes. It's so that I don't have to push Y. It's, when it asks me, do you want to do this? And I would actually have to push Y. But if you put -y up here, you don't have to do that. It saves you some time. So we'll upgrade it all. Yeah, I didn't have too much to do. Most of it was done through the graphical. Okay. We're going to do one more thing before we restart the server. Sorry, I'm always working on servers. Before we restart our Ubuntu virtual machine, which is a desktop actually, we're going to install what's called guest editions from VirtualBox, which is going to give us some better. One, it's going to give a better screen. You'll be able to use full screen. And it's also going to give you the ability to copy paste from your host to your guest, things like that. So we don't need the terminal right now. So let's close it by clicking there, clicking that X. As you can see, the desktop actually works pretty much like the desktops you're used to, whether you're a Windows user or maybe Mac OS. You got your files here. And it actually looks exactly like Windows in a lot of ways. Desktop, documents. These are all the ones that are in what's called your home, which you have the same concept in Windows where you have the user's home, where these kind of files are kept. What gets different is we go up here and we go to other locations. Here's where you can actually go up into the actual files, the system files. And this is where you start seeing some of the files that I went over on the slides. We'll get into them, but since we don't usually interact with them from the desktop, I'm going to show you how to access that on the terminal, because in reality, that's where you're going to be doing that from most of the time. So I'll close this as well. The first thing I want to do, like I said, is that we actually want to add a little more versatility to the virtual machine by adding VirtualBox guest services. So you're going to come to devices, because remember, this is literally a computer inside a computer. It's like, totally Inception. So we're going to insert a CD called Guest Additions, and you're going to click this. And then that's going to literally insert the CD. And then the auto run will come up and you tell it to run. And then it's going to ask you for your password. And then you'll see that it's installing it. Okay. And then, of course, it says, it's not going to be usable until it restarts. So let's go ahead and restart it then. You can actually come up here to Machine, and you can click Reset. And that will reset it, just as if you've, flipped the switch kind of thing. And as you'll see, when it comes back, we'll have some nice abilities that I'll show you. Okay, so we restarted our virtual machines since installing guest editions. You can know that it worked when you go into View and you come here, and then now these aren't grayed out anymore. These will resize it to full screen. So for me it's 1920 times 1080, and it'll make it full screen. Now, in case these aren't available, these resize, let's say they're still grayed out, it means that guest editions, for whatever reason, didn't install properly. If that happens, just make sure, come to optical drive and go to remove disk from virtual drive. Actually, you should do that anyways now, even if it did work, just to remove it. For some reason, you have to do a force unmount. It doesn't like just coming out. So just click force unmount and that removes it. Now, if for some reason, like I said, your virtual editions don't load properly, turn off the virtual machine by going to shut down here, or you can actually just click this, the X, and then it'll say power off the machine. You can click OK, and then turn it back on, and then try it again, because sometimes virtual machine it works 99% of the time, but every so often, for some reason, it doesn't quite load it. So we need to make sure that it does. So just, insert guest edition CD image again. It might tell you that it's already loaded in there and that you're replacing it, and just type yes, push enter, and you'll be good to go. So, because I've had it glitch every so often when it loads it on virtual machines. Okay, so I'm actually going to switch back to a scaled view, because when I have the terminal on, I want you to be able to get a nice big picture of what I'm doing. So I'm not going to be using the desktop a lot. I'll go over it briefly right now, actually, just while I'm talking about it. So here are what's called your favorites, which, they're your pinned applications. By default, it comes with Firefox web browser, Thunderbird Mail. I don't usually use that, so I'll actually remove it from my favorites just like that by right-clicking. Rhythmbox, again, I don't tend to use it, so I'm removing it from my favorites. Libra Office Writer. Libra Office is kind of like an open source version of Microsoft Office. You can use it if you like. I prefer to use Google Docs online, so I always remove it from my favorites. This is actually a pretty useful application. It's a nice little visual software store. It's kind of like on your phone, when you want an app and you want to look it up and install it from a location that you trust, then you can come on here and it will show you different software that's available for Ubuntu, and it will install it for you. But we're not going to wait for it to download the catalog right now. I don't tend to install software using it, but if you like desktops and you like doing it that way, like on your phone, then that's always good. There's a help. It has a lot of information. If you have questions, this is usually a good place to start. Obviously, if you have a question from this video, please just throw it in the comments. But, if you're on your own someday and you need something, they have a pretty good help, actually. So we'll leave that on favorites. Now, if you install applications, they're not going to show up in your favorites automatically. You got to come down to Show Applications. Then they'll have frequent, okay? And these are the ones that you use the most. What you want to do is go to All, and you'll see that there it is. Again, Linux desktops tend to work a lot like phones. Well, guess what? Droid's based on Linux. It's a very modified version because it has a lot more separation and sandboxing, but it is Linux based. So that's why, again, if you think of it more like a phone, the desktop starts making sense. So these are all your applications, and let's say that I use, I don't know, utilities, and I want it on the favorites. It's not there. Let's see, what will I do? That's a good question. Oh, that's because it's a folder. Okay, never mind. That's a bad example. Let's say I want to play Mahjong. If you read the book or watched the movie, Joy Luck Club, you might want to play Mahjong a lot. So you can add to favorites, and there you go. It's always going to be there, and you can play all the Mahjong you want. It's a cool game if you ever get a chance. So I'm going to remove it, though, because I don't plan on playing Mahjong right now. So yeah, and then to close this, you can just push escape, and it closes it. If you need to change your network settings, right now it's showing that this is wired, because it has a virtual interface and it just thinks it's plugged in. But again, it works a lot like Windows or your phone. You come in here and you can turn it off. You can go into the wired settings. Here you have, Bluetooth settings, background settings, appearance, all the desktop type things that you're used to being able to get into and fiddle around with. So that's a quick way to get to settings, actually. Privacy settings, counts. So you can do almost anything, on the computer using the desktop. But the cool thing is with Linux is you can also easily do things on the terminal if you don't feel like doing them on the desktop. So if you had a wireless connection, it would show up in this same thing. It would be available. It would have a button like this, and you could turn it off and on. Obviously, if you click this little arrow up in the right, it brings all this up. Turn it on, lock it. There's settings again. Tells you, well, I'm on a battery, so because it's a laptop, so it's fully charged. It's kind of neat. Virtual machines, when they go to read the battery, they actually read the system battery on your real computer. So that's kind of neat, So if you start running out of charge, you'll still know. And then, of course, volume control. That's my battery there. I'm not going to go too much else into the desktop, in particular, because it pretty much works a lot like Windows. You can open files, you can make new folders. There's properties in there. It's pretty similar. Your knowledge will transfer over, which is convenient. Today we'll be doing part 2 of our Intro to Ubuntu. In our last video, we went over the history and basics of the Unix-based operating systems that comprise Linux. We set up an Ubuntu Desktop on VirtualBox, and we went over the desktop settings. In part 2, we are going to now dive into the command terminal and really get you to that pro level by teaching you how to use Linux from the command terminal. So let's get started. Now, let's get into my favorite part, and this is where some of your knowledge will grow, and that's using the terminal. So again, I'm going to hold Control Left, Alt at the same time, Control Left, Control Alt, and I'm going to push T, and it'll bring me my terminal. And let's see if I can scale this a little more. So, and I'm scaling it, by the way. I'm just coming in here in view, and then I'm picking a percentage, basically. Yeah, that's a good one. I think that's big enough. So, first of all, one of the important commands to know is ls, which basically means list. So it's going to list all the files and folders that are there in that directory. This is my home directory, by the way. You can tell because I'm IPN, and then it's at, and then it has the name that you gave your computer, your virtual machine. I called mine the Defiant because I love Star Trek Deep Space Nine. Now, notice this little picture, this little squiggly, which is actually known as a tilde character. It's telling you that, there's going to be a location, a file location coming, and then it has a $sign. And what this means is that you are in user space. What that means is that IPN isn't the root account. It is a user account. And it means that, it just reminds me you're in user space. We call it user space because users can either have, they usually have reduced privileges. And if they do have admin access, then they have to remember to use sudo to use it. Versus a root account, which would actually, I can actually show you this by typing sudo su, and then it will ask me for my password because I use sudo, and it will ask you for it if you don't do anything for a while. It'll ask you for it again. And notice that the $sign has now changed to the hash symbol. It kind of slanted. And the reason it's done that, and I'll tell you what that CD change directory, when you push change directory CD by itself, it takes you to the home directory of whatever user you're using. So right now I'm in root's home because I changed to root using sudo su. That's just the command to switch to root. And then I pushed CD because at the time I was still in IPN's home, but I just like it looking cleaner, so I pushed change directory, but I didn't tell it what directory, so by default it went to the home directory of the user that I told it to log into, which is root. I just wanted to show you, notice we're not in user land anymore. You are in the root account. You no longer have the $sign. But best practice is you don't want to do things as root. For a lot of reasons. You can break things when you're in root that will actually destroy the system. You can, erase everything. It's really bad idea. Plus, from a security standpoint, you don't want your users, even your admins, using root because let's say your admin either makes a mistake and something breaks, or let's say you have a malicious insider, meaning that one of your admins is an adversary who is doing a cyber attack against you. And they always log in as root, not their user accounts. So when something happens, you just see that it was root. But hey, guess what? It could be anybody that knows that password. But if you're following best practices, then it would be, say, IPN, and I would have to use sudo. So the log of that command would be under the IPN user or whatever their username is, and not root. So, you would know exactly who did it, whether it's a case of something needs to be fixed and you need to check what they were working on, or in the case of a malicious insider and it's somebody that you need to apprehend. Okay, so I went into the root using sudo su. Like I said, unless you absolutely have to, you don't want to do this. For most beginners, you'll never have to do that. Okay, so the way I get back to my original account is I type the command exit, push enter, and it will take me back to my usual IPN account. Now I can type clear, and obviously that clears everything for me, so it's nice and clean. So what I was getting across was the ls list command, and I told you that it shows you all the documents and files, but the interesting thing is that's not quite true. It shows you all the visible documents and files. If you need to see everything, including hidden documents and files, you actually do list or ls -a for all. And then this shows you files that are not meant to be messed with, or for some reason they're being hidden from users that they don't want poking around in them, and they're made with a dot in front of them. such as the bash history, which has all the records of the commands you've used and everything, your bash profile, and the scripts that start up, and some of the VirtualBox client files, just things that you usually don't want a regular user messing with. A lot of times they'll have different protections on them, file protections, so that they can't be accessed by everybody. So that's the difference between the ls and the ls-a. Okay, I'm going to clear again. I like to clear a lot, especially if I got it zoomed in like this and it takes up a lot of the screen. Now, obviously, I can full screen this at least, make it a little better. So let's see, we did the ls and we can see the documents. Now, some of these commands are going to be exactly the same. If you're used to the Windows command line or Windows PowerShell, so, bear with me if you're getting a little bit of a repeat. But for those of you who don't use the command prompt a lot on Windows, then this is, really good to be seeing the basics here. So let's say I wanted to go into the music directory, then I would, actually, that's kind of a weird one to go into. We'll go into Documents. I would do CD, which is change directory, and then I type in the name. And notice it now updates my location, and it's /documents, okay? So what it's telling me here is that I'm, the rest of the path for the home is still there, but I'm in the documents. So it just shows you, what current paths that you've moved into is what it does. And it just keeps adding them that way. So I'm going to show you how you make a directory. Like, let's say you want to make a folder. It's make, which is mk in this case, and then directory, which is just dir. So mkdir, and then we can name it, and let's just call it yellow. Okay. Now when we ls list, yellow's there. Okay. And now we can cd into yellow, and there you go. If you wanted to, say, make a file that didn't exist yet, you could use touch, and then the name of a file, example, and let's say we wanted this to be JSON in the future, which is the one of the most used web formats. Make it. This is a nice thing, by the way, about Unix-based operating systems in general, is that you can basically just put whatever extension you want, and that's the kind of file it is. Because remember what I said about it treating any file just as a file, just as data. So, you can change that very simply. Now, here's a tricky one. If you want to rename the file that you just made, what you actually do is you move it, but you move it in the same directory. So the way you move a file, by the way, is mv for move. And then what we would do is we put the name of the file. Now, usually what we would do is we would put another location, okay? So like if I wanted to move it somewhere, I would usually put the location. I would put / and then let's say we were moving into etc, where the configurations go, then I would push enter and it would move the file over there. But we don't want to move the file to a new file location like this example would. What we want to do is rename it. So what you do actually is you don't put a different directory, you just put the new name. So we're just going to call this new name.json, and you'll see that it renamed it. Okay, now if we wanted to copy the file, then it's just cp, and then we'll just give it a new name. You don't have to new name it, by the way. You could actually just put it in a different folder, and then it would just make the copy. But I don't feel like moving between directories right now. And then both of them are there. So that's your changing directory CD. making a file in the directory without going into any application, touch, and then the name of the file, including whatever extension you might want to have it given. So like if you wanted this to be text instead of .json, you would put, example.txt, and that makes it a text file. Okay. So then to move files around, you put MV, the name of the file you're moving, and then whatever the file location is that you want to move it to. Now, if you want to rename the file, you do the same thing, but you don't put a different folder. You leave it in the same folder and just write out the new name. Like I showed, copy is CP. Now, I want to show you one of the most useful things available. And actually, real quick, just to make this easier, we're going to... Actually, no, I want to show you two things at once. So we're going to just keep it the way it is. I want to show you how an easy way to move multiple files at one time on the command line. Because this is actually something I wish I had known a long time ago when I first started with Linux. And I'm going to teach it to you on your first lesson. So if I want to say move both of those, we'll move them. We're going to move both of them to the IP and home directory, that first top directory. So the one that originally had these file locations, okay? Now we could do it one by one, or we could use what's called a wildcard symbol to grab both of them at the same time. And we're going to do that second one. We're going to do it fast. So we're going to do a move MV. And what we're going to do is we're going to put an asterisk. Now the asterisk is called the wildcard. And it's called a wildcard because it can mean anything. So what I'm literally saying is anything in this directory, move it to this other directory, no matter what it is. Now, usually you might not be moving everything that's in a directory all at once. So I'm going to show you one method to make this a little more efficient. And actually to do that, to demonstrate it, we're going to make one more file. We're just going to call this don't move text. Because this is going to show the power better than the previous example. Okay, so I have these three files, right? I got don't move text, new name 1 JSON, and new name JSON. So you might ask, okay, so how are you going to use a wildcard to just move the two files that are JSON? Because this is something that comes up a lot when I'm working with different programs, and I got JSON files and other types of files, and I want to move some but not others. Well, you just got to decide. It's kind of a fun little puzzle, actually. You just got to decide what's similar about them and what's going to match. So I could actually do this a couple ways. Okay, so I'm going to put my leader, which is the asterisk. First of all, these both have name in them. So I could actually just do anything with name, and then it'll move them. The way I prefer to do it, though, is by their extension, because that's going to be the same even if their names don't have anything in common. Because in this case, notice that these have different extensions. These two are JSON, this one's a text. And like I said, this is the biggest use case that I have, which is why I'm showing it to you. Because a lot of times, let's say you'll want to move the JSON files, but there might be a few text files or MD markdown files, and you don't want them moved, but you just want all your JSON moved. So I do MV for move. Then the asterisk, which again is the wildcard, which stands for anything coming before it that then follows with .json, move it. Now I'm going to give the directory I'm going to move it to. Now I want to move it to my home directory. Now to move it there, my home directory is above us. So I have to give its full path. I mean above us in the sense that, as you can see, we're in yellow, right? And IPN's home is to the left. So it's really to the left of us. But, you can think of it like a hierarchy going above, right? It's up and then up. So what we're going to do is just give its full path, which is good to know. So its full path, again, is /home/IPN. Now, if we give a cd command and we do an ls, you can see that only the 2 JSON files were moved. And both of them were moved at the same time. It's a useful thing to know how to do using wildcards, because it makes it easy as well when you want to erase something. Let's say I don't need those 2 files anymore and I want to erase them. I can actually erase them using that wildcard, that same wildcard. So when you want to remove something, it's literally remove, rm. Then I'm going to tell it just remove what has a JSON extension. So anything followed by .json. Do that, type ls again, and there you go. It's all gone. Now, one thing you should know, if you make a directory, let's make a directory called delete me. Okay, so now we have delete me over here. When you want to remove a directory, you have to give it a command called, well, it's not a command, it's an option called recursive. And then what that does is it says delete the directory and everything inside of it. Otherwise, it won't understand what you're trying to tell it to do, because remember, everything's a file to the file system. So it doesn't really see delete me as a directory per se. It really sees it as a file that holds other files. So you need to tell it to recursively, or going through every iteration or every cycle, delete everything. So then we can type delete me. And then if there had been any files in delete me, it would get rid of the directory and anything in it. Okay. So that's some of the basics of the file system. We'll get into a few more important commands with files in a little bit when we get a little more advanced and we get into permissions and such. But first I want to show you another important one that you'll need to know off the bat, which is how to check your IP address and your network settings. So it's just IP ADDR, and then there you go. So this is going to be, your first one is your loopback, which, is obviously just your internal, 127.0.0.1 address, just on your internal. And then here we have the second Ethernet port adapter, network adapter, which is the ENP0S3. We usually just say this as EPOSI, just because it's fast, and then 3, so ENPOSI 3 is one way you can say that if you choose. I like to. Then your internet address is, in this case, on my home range there. Again, I have it bridged, so it's actually getting just, a random address from the router. Then it has its IPv6 if you happen to have that turned on. Most of them aren't at this point, especially on a home router. Okay, so that's important to know in order to be able to look up your IP address, or in this case also your physical address, your MAC address is also on here. So you'll want to know how to do that. Okay, so we're going to come to clear, and we're going to move on to the next set of commands. Okay, the next subject that I'd like to cover before we get into some more complex commands and networking tools and all that, I want to cover the text editors that are included in Linux distributions. For the most part, each of these will be in there. Now, as you know, when you have a desktop, okay, you have different, you have the Office tools. You can download maybe a text environment such as Notepad++, or Atom is one of my personal favorites for coding. But you're not always going to have a desktop. For the most part, if you're doing IT work, you're going in security, in fact, too, you're going to have, just shell access to that environment. So you're just going to have the terminal. That's just how it works with servers, or if you're using SSH secured shell access. So again, I'm going to hold left Control and Alt and push T, and it'll bring up my terminal. Okay. So these text editors just operate in the terminal itself. They do not require a desktop. So if you're on a shell, access that doesn't have a desktop, this is why we have these in Unix-based systems, so that we can still edit text files, because you need to do configurations and such. So I'm going to show you a couple of the most popular built-in ones. My favorite to use is Nano, because it's relatively simple and straightforward. So we're just going to make a new document. So I just type in the command Nano, and then I'm just going to call it my Nano, and we'll make it text, just for fun. We don't have to, actually. You don't have to give it a file and extension in Linux, which is pretty neat, but I'm going to, just for example, to show you how easy this is. Okay, so I am typing some text for this tutorial in Nano. Okay, so as you can see at the bottom, the little up caret means that you have to hold left Control, and then you can push whatever letter or character is there. So if I wanted to say search for a single word and replace it with another, I would hold left Control and then push the backslash, and that would look like this. And let me not push it a million times. And then you have different options here on how to do this. I'm going to hold left Control and C to cancel. Now, if I want to save it, I can actually just go to Exit, Control X, and it's going to ask me if I want to save it. And I just put Y. Then it's going to ask me, do I want the same name or do I want to rename it? So I'm just going to push Enter to accept the file name that's there. And so now, when we do an ls, you can see that my new file's there. Now, an older text editor that's still very popular with a lot of Linux and Unix-based operating system users is V. So we're going to do that as well. So we'll just call this my V. And again, just to show how easy this is, let's say I wanted to make it in a markdown. I can just put MD, and it makes a markdown. So V can be a little confusing for newcomers, just because there's some buttons that you have to know, and so that's why I'm showing you. Okay, notice right now I can't type in it. I actually have to, let's see, yeah. Wow, haven't done this in a while. That's sad. Yeah. Okay, so take 2 on using V. So when I come into V, I'm not going to be able to type in it. I have to push I, and it lets me insert at that point. And then I can type whatever I need. So I, and then my text being written in V. So the nice thing about V, which gives it, its charm, as you might call it, is that it will show you what line number you're on. Which is very useful if you have a very long file, and let's say there's an error somewhere and it gives you a line number. Nano won't give you the line numbers, so sometimes just because I want to check the line, I'll use V, and then maybe I'll cheat and go back to Nano. But it's all good, whatever you want to do, whatever your preference is. Now here's where it gets a little tricky, is you have to know the buttons to get back. To get out of it. It's actually a running joke that new users spend most of their time stuck in V because they don't know the shortcut keys to get out. Okay, so the shortcut key to close it, sorry, my keyboard's going off on me here. The shortcut key that's important is left shift and the colon symbol, because that will bring you down here. And then I'm going to use Q, and notice that I haven't given it a write command. So it's telling me, hey, you can't quit, without saving unless you overwrite it. So I did this on purpose so you can see, one, how to quit without saving, and two, how it nicely tells you there's been no write command. Because notice it says, hey, you got to add a exclamation mark if you want to quit without saving. So instead, I'm going to tell it to write it first, and it will tell me, yeah, it's written. And then I'm going to push Control Shift again and go ahead and tell it to quit. And this time it will quit. So those are your two main text editors. Like I said, I prefer Nano just because I find the shortcut keys easier to use. But once in a while, V is not so bad because you'll want to check lines or whatever you might be doing if you're not running a desktop and you just got to do some quick configuration on a server. I've been there plenty of times. So I wanted to make sure that we went over those text editors. Okay, let's move on to our next topic. Okay, next up, I want to start digging into some of the most, in my opinion, useful Unix commands that are system, kind of tools. And so we're going to open a terminal again. If you don't have it down yet, left Control, left Alt, and T. Okay, I'm going to maximize this to make it easier to see. Okay, so the first one that I want to show is how you look at processes. So you can actually just put PS, and this will show the processes that are running just for this user by itself. As you can see, I'm running a bash terminal, which is what you're seeing here. Okay, it's the terminal itself. It's called bash. I'll explain that a little more coming up. And then obviously I'm running processes, so it's going to show that. Now if I want to see all processes being run, I can actually give the option -A, and then you'll see that I'm running a GNOME session, which is the desktop. So on a Unix machine, the desktop that's being rendered for you, being drawn for you, as you might call it, is actually considered a process that's running, and you can see it. So that's basically how you use it, but let's dive into a few more of the options. By the way, the best way to do it, especially when you're a new user, and even when you're an old user, don't pretend you don't do this. Google is your friend, because there are a lot of options. There's a lot of abbreviations. Don't try to memorize it all at once. My best advice is the more you use it, the more your mind will start making associations with it. But like I said, you can't always remember everything. So what I like to do, for instance, is actually just look on Wikipedia, because there have been users out there who share their knowledge with everybody so that we can all understand what PS is telling us, what these different abbreviations mean, what the different options are. So yeah, it's really useful that way. Now notice it says, I want to highlight this here, and actually, hold on, let me make this bigger so you can see it better. I want to highlight here that it says PS is often, let me do this, is often run with the -EF, where E selects every process, okay, so that's all your processes, and F chooses the full output format, okay. You can also do -L, which will let you do a log format if you wanted to do that. So let's go ahead and try running that. And this is the best thing to do, by the way, if you want to know what something does, just run it, just see what it does. Unless it's remove everything. You never want to do that one. So never use RM. Actually, I'll just show it to you. Never do something like this, because this is bad. Actually, I think it's like this. Yeah, it's like this. I think there needs to be a recursive in there somewhere. But never do anything that resembles this, because that will literally erase your whole hard drive. Like I said, I could have that wrong, but you shouldn't know how to do it anyways, because it's a bad thing to do. Some mean users out there will try to get new new people to do that, but luckily most people are supportive. But just remember that on Linux, especially if you start using your sudo powers as a root user, you can actually do something like that pretty simply. They don't make it as hard as it is on Windows. So let's go ahead and do that. So we're going to do PS, and then we're going to do our option, which is -EF. Okay, so now, as you can see, we get a lot more information. It's going to show every single process, not just the ones that are running up front, and it's going to show all their information. So let's go ahead and go into this. Okay, let's look at this a little closer. Okay, so we got the user ID, which is, okay, so there's a lot of things running under root, obviously, because those are system. There's loopbacks, there's all sorts of stuff going on. Then there's IPN, which is, the user account I'm using. Everything's given a process ID and everything so that they can be done. They'll be stamped with timestamps. And then they'll show the command that actually started it so that, that can be logged. In security, this is something that you're going to be using a lot, these commands, because you want to make sure that, attackers don't use commands that are native. We call them native tools to, pivot around your network, steal credentials, things like that. So you'll be monitoring these commands quite a bit. So that's why it's a good idea to actually look things up, and just take the time, take the time to know what it all means. Just read through this. So notice this, PPID is the ID of the process's parent process. This is a big concept in processes, by the way. Again, it's going to come up in security if that's going to be your roadmap. And to be honest, any IT should understand this. Okay, you have a process, right? Which is, a service running, a program running, whatever it is. But in a system, in an operating system, there's always going to be a parent process that is going to be the starter, it's going to be the hierarchy of how this was started on your device. So you're going to want to know both what the process ID name is, but you're also going to want to have the parent process ID. And you're going to want to understand that event cycle where a parent process will spawn a process. Because, for instance, you might have a process like Excel, okay, Microsoft Office Excel, that's perfectly benign. It's usually not very, everyone uses it, so why wouldn't it be running? But if it's launched by a parent process that's in your, downloads folder, that's not normal. So yeah, that would be when you want to go check out what's going on. And so that's another way to check on the command line. Because the command line notice it gives the path that's being used. So these are legitimate paths, okay? These are, like I said, USR, the user, SBIN, cron, for instance, which is a scheduled task, okay? It's a reoccurring scheduled task. I'll show you how to make those a little further on in the video, but those are important because those are things that are run on your Linux machine, whether it's a desktop or server, all the time. And what attackers will do is they'll create cron jobs of their own so that they can do things on your system. So you want to keep track of what these paths are on the commands, because if they're somewhere fishy, that's not normal, you need to know. You need to know what those fishy paths are going to be. So just take some time. Again, you don't have to try to memorize everything in a day, but just take some time to scroll through and find out, what are some of the normal commands and paths that you're going to see, because that way when you see something that's out of sync with what is normal, you'll be able to tell really quickly. Like, for instance, if you get a detection rule go off and it says, hey, this process is, looks kind of weird, can you take a look at it? Then you'll be a much faster analyst, and being able to tell, no, this is a false positive, it's safe, or hey, is this something we should elevate and have a team look at? We want to be those fast first responders, and really just take the time to scroll through this, become familiar with it, and it will make you much more powerful, in your professional career if you do that. So I highly encourage you to just spend some time reading through this Wikipedia article on PS in Unix. Again, this applies to any Unix-based system, so it's pretty awesome. And just take some time to get used to it and how to use it, because Linux actually gives you a lot of data telling you what's going on right on the command line. So you can do a lot of your security work right on the command line. And the more you understand that, the better you're going to be when you're dealing with alerts. Like I was saying, you're going to be able to react faster. You're going to speed up your time to deal with the event and close the case. And that's what you really want to be working on, is that response time, because you don't want to become one of those security operations centers that gets burnt out because they're not working through their alerts quick enough. Okay, so that's kind of my talk on PS, because it's simple, yet it provides so much beautiful information for you. And while we're talking about these kind of things, I want to show you this Grep command, because Grep allows you to grab, it's basically a way of taking the output on the screen and then filtering it for a single result. It's literally next to, I think it's AWK, which is another text searching tool that's built into any Unix-based operating system. It's one of the most powerful tools for searching for things on the command line. So what it is like you'll put PS-A, okay, and then you'll put, this is called a pipe. It's actually, if you push Shift and backslash on your keyboard, it will make one of these little vertical lines that we call a pipe. And what a pipe does is it takes the output from the previous command. So here, actually I'm going to make this even bigger because I want you to really understand this concept. Okay, so it takes this command, PS-A, so super all, your processes and everything, and then pipes it, and then it greps, or kind of like a get, right? It greps Firefox. So that way, if you just wanted to check out what was going on with Firefox and not everything that's on your system, you can do that. And that becomes really important when you just want to check on a single service. Like let's say you're running an Elastic stack and you just want to check on Kibana or Elastic itself, then you would grep Elastic search or grep Kibana, and that would that would just give you that single result. So, and you can do this with anything. You can literally grep any file. So it's pretty cool, actually. So I'll give you an example. Let's see, let's clear all this. Okay, so I have this text file, right? Well, the cool thing is that there's this command called cat, which is basically copycat when you think about it. That's how I like to think about it. I don't know if that's what it is, but hey, it's cool. And it actually reads out. It just puts out to the terminal what got typed, what was on that file. And by the way, I want to get one more kind of important concept to you early on, which is everything that I'm typing into the terminal, it has a name, and it's called SDN, okay? So anything that I type in is known as SDN. It is the terminal input, okay? So anything that goes in also has to come out, right? So then you have STD out. I think that's what it's called. I'll double check it, but STD out. And what it is anything that comes out here is STD out. Okay, so you have STD in and STD out. Because when they created Unix back in the old days, this was all just text going back, in and out, and they just wanted to treat all files the same. Remember, that's the philosophy here. So what they did was they created a universal input, STD in, and a universal output, STD out. And so that's a powerful concept to realize. Okay, so we're gonna show off grep. We're gonna show it off now because we want to show you how stdin and stdout works. So we're going to do cat mynano.txt. Okay, so that's going to be our out, right? So then we're going to pipe it, or we're going to take that text and we're going to send it over to another command, and we're just going to grep the word typing. And notice that when stdout comes out this time, it has grepped typing. And in this particular format, it's highlighted red. So what it would have actually done if this was longer is it would have looked for any instance of the word typing. And it would have highlighted them for me so I could see them. So that's a pretty useful command. And I highly suggest that you do some playing around with grep. Look up its Wikipedia article, because there's a lot of neat things that Unix can do. For instance, you could actually pipe that again and then give a command that counts how many times typing shows up. And you could get that number. So even if you don't have your logs going to, say, Elasticsearch, you can actually use the basic text editing and text searching tools on the terminal to really do some hunting. And that's how it was done back in the day, and that's how a lot of the best analysts are still able to do it. Again, another one, I'm not going to go over it because it's a little beyond the scope of what we're doing, but awk is another really good one. I suggest you look into if you're interested in learning a little more about how to navigate the terminal for log analysis. Just so you can get that first responder on the server type thing. In case you don't have the fancy CM, or let's say your big system, your monitoring platform goes down. Well, you can you can save the day, because you can say, no problem, I can still analyze the logs. So these are important skills that you want to be the best out there. You want to be an IT pro. So you want to know how to use grep. You want to know how to use awk. You want to show them that you're a pro. You're not just fly by night. Okay. So that is grep and processes and how you use pipes. All right. Okay. Our next command that we're going to learn is called Netstat, or net statistics. Funny enough, they don't include this one in Ubuntu off the shelf anymore. Not quite sure why, but it's a very convenient tool to have, and I wanted to go over it because it's a very simple way of looking around, poking around at what your network's doing on the system. So what we're going to do is we're actually going to install it. First, the tool set you need. So what I did was, just to go over again, was I held Control-Alt and pushed T. My favorite shortcut. It brought up the terminal. And I'm going to type in sudo apt install -y. And we're going to be installing what they call the net tools. Okay. These are just some nifty little utilities. Usually only admins are going to be using them. That's probably why they don't have them on there just in general. Okay. So now that those are on there, now we can use Netstat. So let's just start it off with a very simple one. Okay. So all this did is it's showing me every socket connection that's opened on this particular computer here, on this desktop. So it's going to tell you what the protocol is, sent and received, mount, local address, what foreign address, where is it sending it to, and then the state. So is it established? Is it listening? Is it waiting? Whatever it is. And these are different Unix sockets that are opened by different processes. Yeah, active Unix domain sockets. Okay, so that's just like a lot of information at once. Obviously, you can filter this, and we'll go into what some of those commands are right now. Again, Wikipedia is your friend when it comes to looking up these commands, because they'll show you, these general options that are going to come in really handy. For instance, here we can see that they have a -AT. So if we only wanted to see the TCP connections and we didn't care about UDP, then we could do that. So let's go ahead and try that one out. Netstat. And instead of just -A, -T. Okay, much shorter. It's not showing us any UDP. It's not showing us the other sockets that maybe sockets. Sorry, tongue-tied there a little bit. Don't say that word too many times over. That maybe aren't using TCP for one reason or another, and so now we can just see our TCP connections if that's what we want. Let's see what else we got. Okay, if you want to see network statistics and you want to put it into a file there. Kernel routing information. We can look at a table of interfaces. Let's do that. So netstat -I. Okay, and this shows us what two interfaces we have. We have the low back, and then we have ePOSI3, which we know. And it gives you all the different networking statistics for them. So this is, just another thing handy if you want to be a really good admin. You're going to want to have this, general ability down. Because remember, you can always use grep and grab it for any particular type, right? So like, for instance, they're showing you here a good way to grab established TCP signals. So you do netstat -A, T, and P, and then you pipe it into grep established. So that's only looking at TCP signals that connections, that are actually fully established and going back and forth there. And they have some others that can be useful. And I really suggest, again, just taking some time to play with it a little bit and see what it's all about. That's the best way to learn these things. So yeah, if you wanted to see all your network statistics here without putting them in a file, you could just do netstat -S, and it'll show you how much of it's being forwarded in IP, ICMP, so ping and such, TCP, UDP connections, UDP Lite, and IP extension. So again, these are really basic, kind of old school Unix tools. It's actually on Windows as well. I don't know if you know that or not, but Netstat, there is a version on Windows. So these are just really good command line, good old-fashioned terminal tools that you really should know how to use. Because what happens when all the fancy stuff is down? You're not getting your logs sent, your CM's crashed. Hey, guess what? You know how to jump on and get that network data for everyone that they need. So it's really worth it. Take the time, play around with Netstat, see what some of these other options do, see how you can play with wildcards to grab, all sorts of interesting information and how to quickly search it using grep and, pipe it into files so that you can, make a report. Again, hey, it may be only a text file, but when your whole system's down or you need something quick and dirty, it's the fast way to do it. So definitely Netstat, I suggest, again, a command line tool that you really want to have down if you want to be really, really good in IT. So yeah, bash scripting is a very powerful tool when you want to automate something, especially, and it's a complex thing that you don't want to have to do everything over and over again. So what I'm going to do, instead of showing a simple example, I'm going to show you one of the best examples of proper form from a security project that I've used quite a bit. So we're going to go take a look at their GitHub here. And the project is called the HELK, or the Hunting Elk. It's a pretty neat project. Originally started here by Roberto Rodriguez, also known as Cyber War Dog. He's a really nice guy. He's given a lot to the cybersecurity community, and the Helk was one of his first projects that he shared with everybody, and now it's being worked on by a number of individuals. And I liked learning from him, not only about Elastic, but about programming in general, because he's always really good about following best practices. A lot of comments, clear structure, things like that. So that's why I decided to use one of the Helk's automation scripts as the example, because, why not learn from the best, right? Okay, so here you can see that the script's name, let me make this bigger. Okay, so the script's name is Elasticsearch entry point.sh. You can see that right there. Okay. .sh is the extension you'll want to use anytime that it's going to be a script, that it's going to be, an executable bash script. Now, up here, this little guy is called your shebang. Okay. It basically means the magical power that lets it know that it's a bash script. Yeah, they like to call it the shebang. It sounds really cool. We all just go with it. But that's what it is. Literally, that's what tells it it's a bash script. Okay. Now, as you can see, he really comments this out nice. Tells you what the script is for. Tells you the build stage. Gives the authors of it. And then the license on it. Notice that the license on this particular script is GPL 3.0. Basically, this is an open source project under the GPL 3.0 license. So, anybody can contribute to this project, use its code, and, give back to the security community, which is very important. And as you can see, it's doing a lot, but you can follow along because he's commented it out this so well. So the first thing he's doing here is he's naming variables, okay? Then he starts down here setting the elastic memory amount. So he's using if statements, if then, to check different things about the system to see like if Docker's set up, if there's enough memory to be running everything. And you can see that bash scripting allows this all to be done automated. So when a user wants to use the Helk, they don't really have to worry, oh, should I check every little thing? Because guess what? This script will check it for you. It's all automated. And the power of bash is that it can do it and it can fix things that aren't there. So it's really convenient to have this kind of automation, especially when you're working on a community project and you don't know who's going to use the code. It's one thing when you're in a company and you know who might be using your code, but if you're giving something to customers, to users, to people out there, you never know. So this type of automation on the script level, just when installing things like the Helk or other more complicated pieces of software, it's really handy to know how to not only write bash scripts, but be able to write them in this form where it's very easy to see what they're commented out to be doing, and the structure is really nicely laid out. Okay, so that pretty much covers what we're going to go into on bash scripting. There's a lot more out there on it, but this gets across what the power of what it can do and the way to make it work the best way for you, which is, make it very structured. Make sure you comment out your code. The last thing you want to do is write a script at, 12 in the morning or 1 in the morning, wake up and not know what you were typing out. So if you commented it out, especially if you're going to ask questions on community forums, people will be able to help you out a lot easier. Okay, so that's bash scripting. All right, we're coming down to the last few things that we're going to be showing you on Ubuntu. So let's go ahead and Control-Alt-T again. Now I want to remind you again, anytime that you need to update, you just have to do sudo apt update. because apt is what's called your packet manager. Okay. And what apt does is it not only installs all of your software, but it remembers what all their dependencies are. What are all the different packages that, let's say, Elasticsearch is going to need, or Chrome is going to need, or any application that you install on a Linux box that's running Ubuntu. Apt is going to be able to keep track of that for you. So anytime you have to update, you can just do that. Just that, with update, sudo apt update, and then sudo apt upgrade, and I do the -y so I don't have to push yes later. And they call these package managers. Now, if you're running a different version of Linux, let's say CentOS, which is based on Red Hat Linux, then you might have a different package manager. The one that they have is Yum, Y-U-M. So if you're working on CentOS, you would do Yum update, and that would do the same thing as apt update does. The reason why Ubuntu uses apt is because it is Debian based, meaning that it is originally a project that kind of splintered off from Debian distribution of Linux to create their own distribution, but they're still Debian based. They use apt. Most of the commands carry over. There's a lot of improvements, in my personal opinion, over vanilla Debian in Ubuntu. Obviously, that's just my opinion. There's plenty of people that prefer straight Debian to Ubuntu, and everybody probably has their favorite distributions. And it's really just about trying them all out. See what you like, see what you don't. I know in business areas, you might tend to see more Red Hat and CentOS based servers sometimes for various reasons. Although Ubuntu is getting a lot of adoption these days. It just really depends. The best thing to do is, be versatile, be open. Don't just teach yourself one platform. Teach yourself all of them. Spin up a VirtualBox, after you do your Ubuntu one, and try CentOS out, and see how it is. But the core thing here is that you have these package managers, whether they're apt or Yum or any of them, and they maintain it all for you that way, and it's really nice. The final tool that we're going to get into is the Cron tab. And you can actually access it by just pushing Cron tab, then there, with the -E, and then there. Cron tab -E. Okay, now this is the first time that I've accessed the Cron tab, so it's going to ask me what text editor I want to use. And I want to use Nano, because I just like Nano. Okay, so what the Cron tab is, by the way, is it's a method for automating commands and scripts on your machine. And this can be very useful, especially as an administrator, because let's say you need to update your servers at a specific time, okay? And you don't want to have to do this you don't want to have to update them manually, obviously. Like, let's say you had to update them. We'll use this example. They show an example here, which is really nice to have, which is 5 a.m. every week. Okay. Now, what this is doing here, the example itself, it's backing up all the user accounts. But you could put anything you want here. So we could erase the part that's telling it that, But let me explain how this time is working before we get into the command, okay? This is minutes, hours, days of the month, and then day of the week. And so what this is doing is it's telling it that at 5 a.m. every first day of the week, we are going to do something. And in case you ever forget what those mean, Notice that they put them here for you, which is really nice. As an example, see, they got minutes, hours, and if you put them in these columns, it makes it easier to see everything. And then your command. So this is down here under all the writing is where you would put your new ones. I just uncommented this section because it was already started for me just for the example here. But in the future, you'll want to add new ones down here. Which is nice because they already put the reminders on where everything is. So yeah, at the 5th hour on every day of the week, we're going to do the following. And we are going to do apt update. And then we'll do an and upgrade. If you do the two ands like that, it combines the two commands. So it's like continuing it to a second line almost, but it tells it, hey, do both of these together. And we'll want to remember our -y because that way it knows yes to do it. It won't get stuck on the prompt. So that's one method. Now, Ubuntu Desktop itself has a reminder to update, which is good. But let's say you're running a server, you don't have a desktop, then this is a perfectly good way to update, every 5 a.m. every first day of the week. Okay. And don't worry, that's just for more information. I didn't mess anything up. I can comment it out, comment this out actually too, so that there's nothing there. Now we actually entered the users tab. I'm going to close this real quick with Control and X. I'm not going to save anything. Notice that when we did the command, we just did cron tab -e. What that means is we didn't give it system admin ability. So actually, you wouldn't want to run that upgrade version on that one. I mean, the update command we gave, because it wouldn't run. It wouldn't have that system ability. We did it on the IPN user. If you want it to run something with root abilities, you would have to sudo first. And notice it's acting like it's the first time I've ever gone in. And it's technically true. It's the first time I'm using the cron tab for root. So now I'm in here. Now this is a root elevated cron tab. And again, with great power comes great responsibility. Be careful what you put in here because it will affect all users, all your systems, and you want to be very, very safe when you do these things. Okay, so again, cron tab -e just does it for the user. But if you do sudo cron tab -e, then it will open up for everybody. For the root, which affects everybody, affects the core of the system. And you want to be very, very careful when you're using your sudo power. Okay, so yeah, that's basically a really nice tool that you have on the terminal, the cron tab. You can use it for all sorts of things. If there's anything, a script that you write yourself and you want it to run every time it boots up, you can actually just tell it there's some special words that can be used with the cron tab, and you can tell it when it boots up to do it. You can tell it, do it when a particular thing happens. There's a lot of versatility. Mostly in the past, I've used it to start up different programs I might want to start up or check settings, things like that. Very convenient, very useful. Okay, so that finishes up this introduction to Ubuntu. I hope you've enjoyed it. Please remember to like and subscribe to our channel, and anything that you want to see or any questions you have, don't feel free to comment. And this has been Ivan for Skills Build Training. I'll see you next time.